All right. Good morning, good afternoon, or good evening, depending where you're connecting in from today. I just want to thank you all for taking time out of your busy day to come listen to us talk to you today about the Storyboard product line that helps you accelerate your UI development and design. This is the first of an ongoing series that we're putting out there. So it's really designed to really kind of advance your knowledge, really taking your awareness and understanding of Storyboard to the next level. And it's something we're going to be doing roughly around the end of every single month. So definitely, place a little marker in your calendar or keep an eye out on our webinar section of our website, and we'll also be sending out emails to let you know. But definitely, it's something that is going to really help you really kind of understand Storyboard that much better, but really help you when it comes to developing your UIs for the different embedded projects that you're working on. Of course, today we're going to be talking about how decoupling the communications or events that kind of occur between your user interface and, of course, your backend system logic can really help lead to improved UI development. So just some general housekeeping before we jump into things. This session is going to be recorded, so definitely if you need to jump off or you get disconnected, or if you have a colleague that maybe wasn't on the line today but you feel that would really benefit from what we talked about today, the recording will be posted, of course, on cranksoftware.com within our webinar section, so you can easily access it at any time in the future. So definitely one of the benefits of having a live session like this is that you'll be able to kind of pose your question. And so within the chat window, you'll be able to submit your questions. We'll be doing the Q&A section at the end, periodically through it once I stop talking or other guest speaker stops talking. Maybe we will be answering some of those live, but the majority of them will be answered at the end. And definitely at any point in time, feel free to throw some social kind of posts out there, whether it's on LinkedIn, Twitter, maybe Facebook. Just of course use the hashtag of Crank Software or Embedded UI or Embedded GUIs. And tell us what you think, and give us your opinion, because definitely, like I said, we plan to do this every month, so we have about another 8 to if we continue on to 2021, 12 sessions to go. So if there's something that maybe is puzzling you that you want to hear about, feel free definitely to reach out to us via social media, or of course feel free to reach out to me. And who am I? Well, I am Scott Snyder. I am a product marketing manager here at Crank Software. And so definitely I want to hear from you as to, when you're using the software, what is it maybe you wish, maybe it did that it didn't do, or, what do you enjoy? Definitely feel free to reach out to me at any point in time. I'll throw out my email address right now. It's fsnyder@cranksoftware.com. So feel free to ping me at any time. Also, we're very lucky to have one of the our VP of R&D, but he is one of the VPs, but also one of the co-founders of Crank Software, and that is Thomas Fletcher. And so he is going to be the main speaker today, really jumping in to the communication side and the event side that occurs within Storyboard, and really kind of lifting up the hood and really kind of getting into the engine, so to speak, of Storyboard to provide you a little bit more greater understanding of what's going on behind the scenes. So today's agenda, of course, I'm going to give you a quick overview on Crank Software, just in case maybe you were asked to attend and you didn't know who Crank Software is or what even Storyboard is. So I'm going to give you a quick overview as to who Crank Software and Storyboard is, and then we're going to jump into the actual meat of today's presentation, which is the events-based communication that goes on within Storyboard. We're going to discuss why using events and messaging is really beneficial for you when it comes to the development of your user interface. We'll also talk about ways to encapsulate that complex data that does go on and occurs when you're actually kind of talking to that backend logic. And then, of course, how this all really helps with testing and debugging when it comes to, that important stage of UI development to make sure that it's going to run the way you intended to when deployed upon the target hardware. And then, of course, we'll wrap things up with the Q&A session like I talked about. So let's kind of quickly jump into just a quick overview. It won't take up much of your time. But again, just talking about, the really benefits of, why we're here. So, if this is your first time and you haven't heard of Crank Software before, it's a pretty good chance that at some point in time, you have touched a product or used a product that's running a UI that was built using Storyboard, our UI development software. As you can see, it's across many different verticals, and we have a multitude of different companies. Actually, we have about more than 500 million, devices out there in the field that are running some form of a Storyboard created UI. So Crank Software, of course, is a software and services-based company. And so what does that mean is that, not only do we create the Storyboard software, but we also have a pro services team. So we have a team of experts in-house that know Storyboard, that know UI development. So maybe, you're at a different phase in your UI development. Maybe you're at the beginning, you don't know where to begin, or you need to have a prototype to be able to kind of get buy-in from your executive team. Well, you know what? If you don't have the know-how or the time to do that, you can leverage our pro services to do that. Or maybe you're further along the development of it, and maybe, you just want to make sure that it is perfectly optimized. Again, we have a team of experts that are willing to do and have the knowledge from start to finish when it comes to creating UI. So feel free to reach out to us and to inquire as to how we can help you out there. Definitely, like I said, our leadership team has that extensive background in embedded graphics. They have over 20 years experience in the UI field, and we have a large global base of customer footprints from Fortune 500s to really small organizations. And so, it doesn't matter if you're big or small. Definitely, we're there to help you out to really make sure that your product is the best product possible and give that exceptional user experience, so that way your customers love it. And of course, we offer our customers access to, we have a large global distributor partnership network for that local support, depending where you are connecting in from today. And so just to kind of give you a quick overview, the founders of Crank Software really, set out to build a solution that could really help remove the inefficiencies that not only frustrated them, but their colleagues when it came to developing UIs for embedded devices. So really, Storyboard benefits from over 2 decades of experience in designing and implementing embedded graphical user interface solutions for a broad range of industries. Really, when it comes down to it, Storyboard is really designed to remove the barriers or issues that are typically associated with UI design development. It provides this unique collaborative environment that allows designers to work in the tools that they're familiar with, import those design files, do a lot of the UI development within Storyboard before having to pass it off to an engineer to really kind of start doing the code. But the beautiful thing about having that kind of decoupled environment is it really provides your UIs flexibility. So it provides them scalability to move from MCUs to NPUs or vice versa. It allows them to be, you to come in and at any point in time, change out any piece of the technology stack. So maybe you were going down a certain path of a certain particular product and you realize, it doesn't have enough power, or maybe it's too costly and I want to go to something else. Your UI can go with you that was developed in Storyboard. You don't have to worry about ripping down a bunch of code and having to recompile because that decoupled world allows you to maintain that UI. And our team of R&D have really set forth and created these fantastic embedded runtimes that have been highly optimized for the different boards. So all you need to do is marry up the UI with that runtime engine. So really providing you that sense of UI flexibility, to scale, to portability, as well as, maybe you're in the process of expanding your product lane, and maybe you have a low end, you want to go high end, or maybe you have a high end, you want to go low end. You can have that consistent look, touch, and feel because that UI can easily go across those. So really providing that consistent look, touch, and feel for your product line. And so with that being said, I'm going to kind of pass things over to Mr. Thomas Fletcher, and he's going to talk to you about today's topic.
Super, thanks, Scott. Just mechanically here, I just want to make sure that Scott and I are on the same page. Scott, do you want to just give me full display control? I've got the slide deck up here, and I can just move through it on myself, and then it'll allow me to jump a little bit back and forth in between the presentation and the rest of the topics I want to cover. So
yep,
let's
you have it.
Go ahead and show my screen. So hopefully everybody sees something that looks exactly like what they were just looking at. Nice MacBook Pro, decoupling communication between your user interface and system logic. As Scott mentioned, I am one of the VPs here at Crank Software. I'm also one of the co-founders, and I look after our Storyboard product development line. And so it's my pleasure today to talk to you a little bit about design aspects in terms of how embedded user interfaces can kind of be created and developed in a way that gives you some flexibility around testing, gives you some flexibility around choice of deployment models, where you're deploying, what type of hardware, what kind of configurations, and really gets a whole team mentality of working in parallel, working on both the system components, right? When I talk about the system components, we're going to talk about that in a second, but the back-end logic, the front-end logic, different skill sets, different people, getting them all working together in parallel. So let's take a look here, and we should be on a slide. Looks like typical UI design architecture, big white slide. The idea here is that this presentation isn't about necessarily talking about design architectures, but what I did want to highlight is some of the language that we're going to use when we talk about the UI and the system logic. You may have heard this, kind of concept in HTML, web development, where we talk about front ends and back ends, clients and servers. And this is kind of a cross-cutting language that's independent of, necessarily the computer science view of, your design pattern of what you're doing. Today, we're going to be talking about, sort of the UI and its communication model with the system. And what is in the UI typically when you're thinking about model view controllers, model view presenter, model view models. These are all different triangles that allow you to separate out the logic and the concern of how you're presenting data, how you're presenting your model for your product, and how that model is being populated. And then really, kind of that border area that I've kind of got the controller, presenters, and view models is a bit of an overlap, right? Whether that lives entirely in the UI space, entirely in the system space, or a little bit in both, is kind of an implementation detail. But it's interesting to think about this as a context for our conversations, because really what we're all about here is creating a design that allows us to decouple one element from another. And we're all in the software development profession interested in data hiding, decoupling, ensuring that we've got flexibility of interfaces and our ability to design things. But it's not just about doing that at the code level. We want to make sure that we actually have that freedom of change at the UI level as well. And that's why these architectures are worthwhile kind of just kind of highlighting as we start. Typically, when we talk about interfacing between a UI and a system, certainly in the software development world, we start talking about APIs. And when we talk about APIs, most software development professionals, their first thought is, let's define a whole whack of functions, right? Let's define functions that really kind of describe the behavior of the system, the functionality of the system. I'm going to make this call with these parameters, and I'm going to get this data back, and then I'll be able to work with it in this way. And that's the type of decoupling that typically happens. And this isn't, again, going back to the thought that this isn't tied to a particular technology or design paradigm. This is simply the way software developers tend to think. But one of the challenges with this kind of method of decoupling a UI from a system is that you're getting right into the weeds of the technology right away, right? You're talking about implementation level details because you are talking about, generally function calls. And even if those become abstract, they start to form your thinking about, how data is going to be put together and how it's going to be organized. One of the other things that's, kind of a little bit challenging is that as you start to assemble this system, you really want to keep it decoupled. You want to keep the UI moving forward on its own pace. You want to keep the system logic, device drivers, data providers, things that are fulfilling that data model of what the product is. You want to keep them separate. But in order to keep everybody working, you need to develop a set of shims around those APIs, or you need to have a simulation that brings the entire system along. You can't pick and choose certain elements of the system that you care about for the UI and certain elements of the system you care about for the system logic, and really just isolate those and only implement those as shims as you require them. Typically, you've got this definition, and this definition has to be hollowed out right from the very beginning. It makes it very hard to simulate, and it's not impossible, but it's just a lot more work. And it gets you into the path of some risky parallelized activities. There is a lot of sharing because this whole gray area, this whole API, has to be some shared context back and forth. And as an API, as a language-specific implementation, if you start crossing technology boundaries, right? You have a UI that's implemented in one technology and a system logic in another technology, then you have to start building additional bridges into and out of those APIs. So it's a challenge for sure, and it is a typical way that we think about, sort of separating out the UI and the system today. One of the things that we are big proponents with in the storyboard world is this notion of events, right? And when we think about why we like events and what it is that makes, kind of events as a mechanism for API description powerful, it's really this notion of decoupling, right? You can describe the same sort of API that you would have as a functional API, but if you shifted your conversation around not a function call to do the implementation, but really looking at the arguments that would go into that function call, the arguments that would go into that interface as the data that's being shared, and classifying the types of data that you expect to be shared back and forth between the system, between the UI, or maybe even between other elements of the system, it really starts, sort of abstracting away any particular implementation and giving you this idea of, what am I really working with? What do I need to provide? And what am I able to receive in terms of now my component, whether it's a UI component or system component, can go off and do their work, right? And so the event is a bit of an abstract concept, but it can be also applied directly to a large number of kind of system implementations, whether it's a message queue implementation in terms of the transport, something that's a single process model where you're all working inside the same memory space. And so this is really a synthetic, kind of a virtual separation between the UI and the system. And again, we can do system. We're only talking here, kind of today's context about UI and system separation. But this notion of, synthetically creating a separation is important because that single process model, maybe it's a real-time executive, right? Maybe it's something running FreeRTOS. It's running a very small memory model, so there's no need for a memory management unit. But then as you scale your system design up, maybe you're into something that you're a little bit more of a fuller operating system. And so your UI is actually executing in its own process. Your system is executing in its own series of processes. And now you're using an IPC mechanism, right? Something that allows data flow back and forth across a process boundary. If you were doing a functional API, again, now what you'd be doing is you'd have to be burying this behind some sort of an implementation sitting inside of your library. But the thing that really gets us excited about events as sort of a way to model your API and as a way to connect to your UI and your system process together is what we can do in terms of keeping things separated and agnostic. So I can move single process, I can go multi-process, and now I can actually also go distributed. Because our endpoints are interested in the data and not the transport. Our endpoints are not interested in how the data arrives. They're simply interested in the data that they need to package up and provide and the data that they have the ability to receive. And so this allows us to do things like push data into the cloud, right? Use a network connection, right? Use some sort of other brokered connection that connects the UI and the system processes together. And again, what's interesting here is you're really not changing your API thinking, and you're not changing your implementation model. You're really just changing the way that your data is moving around. So this is a Storyboard advanced user training session. So I am going to, sort of flip around a little bit between generic content and kind of generic best practices and things that are Storyboard specific. And soon we're going to jump right into the Storyboard workspace, and we're going to look at, look at our typical coffee example and build it up. But just to kind of provide a little bit of a refresher on what a Storyboard event is all about, if we're talking about using events as API and events as data payloads, or as events as a mechanism for us to carry data around, we have to kind of understand what our possibilities are with the technology that we have today. So Storyboard deals, everything is kind of triggered in terms of events. And for us, event data is really a serialized memory block. It's a pretty low level of abstraction. It does, kind of tie us a little bit more closely to C as an implementation language, but we're an embedded UI, so that's a kind of a reasonable assumption. And what's important here is that as a low-level abstraction, there's lots of other layering that can be done on top of this. We provide some basic serialization functionality that allows you to describe what we would consider as standard contiguous blocks of memory, generally aligned with C type of data structures. And so one of the things that's important for you is, as a developer of an API, as a software developer, as a developer of a UI, kind of understanding that your data is going to come along with payloads, and that those payloads have to be described, and they have to be described in a way that allows some interoperability between the user interface elements and the embedded kind of platforms that may be providing that data. And so one of the caveats, and this is a bit of a plug for our Storyboard training course, where we go into this in a little bit more detail, but one of the things that you need to kind of be aware of is that because we are mapping down onto a contiguous block of memory, our event data kind of has to be a little bit aware of alignment. But what if you have complicated data structures? What if you have kind of highly dynamic content? What do you do for serializing those type of situations? If you have that type of situation, and it occurs fairly regularly, Storyboard IO may not be, or the Storyboard event format itself may not be the right choice. It can still be used as a transport. You can still use Storyboard IO for inter-process abstraction, but what you'd be looking at doing is taking that event data payload and actually packing it in, and using that as really just a byte stream to move data from one side of a barrier to another. So if I look at the anatomy of an event, a Storyboard event typically is always defined with a name. Can have a target field in terms of if it's directed event data. For example, if I'm looking at something like communicating a press or a variable payload, I want to direct it. That addressing is a little bit, it's a little bit client specific. The format and the data are really the two pieces that go together. The format is a string that describes what the data payload would look like, and the data, of course, is the bytes to be transmitted. And so that data, if you want to apply a different encoding on top of it, right, some sort of higher level serialization, there's no problem here. Here what I've done is I've just kind of called out 3 different types of scenarios where you might have a JSON string, right? Typical if you're interfacing with the web world and you're using some common backend technology there, you may be receiving packets of JSON data, in which case your data payload is probably just going to be defined as a string, and then that string can be parsed inside the engine and turned into kind of application specific data. A lot of times people wonder about the ability to do something that's not string based, right? So a good example of that would be something like protobufs, right? Which is Google's serialization technology. And really a protobuf is a definition that allows you to pack and unpack data between different languages in a lot of different formats, and supports revisioning and history and some kind of fairly rich data structure attributes. But ultimately, it comes through as a byte payload. And so a protobuf stream might get packed as an array of unsigned bytes inside of a storyboard event and then transported across, right? This isn't to say that you couldn't use socket communications directly, but it's nice to stay native in terms of storyboard events when you can. And another technology, and I'll just kind of give it a bit of a shout out because Storyboard tends to be very Lua centric. We really rely on Lua as a great scripting language, as a great technology that fits in a lot of tight embedded spaces, low resources, highly performant, but to give us that glue logic, right? And so if you're looking at designing a system from scratch and you have the flexibility of using Lua kind of in a bit more universal sense, you could actually pass Lua serialized data around. And there's a library for serializing rich Lua data structures called Serpent. And so the Serpent stream looks a lot like the JSON stream, probably comes through as a string as well, and then gets unpacked as well. So just a bit of an event refresher. It's kind of a bit of a broad topic here, and we'll see it a little bit more when we get into the workspace itself. So one of the common questions we get when we're doing our training sessions, when we get into the conversations of, well, I like the idea of doing event communication, and I can see how I can replace my functional API that I would develop with a more event and data-driven API. But what are some of the rules? What are some of the kind of the pitfalls, and what should we be aware of? So my first thing is that one of the things you want to be careful about is mixing and matching. When you're thinking about UI, you're thinking about flexibility. You're thinking about different presentation models, and a lot of times, people will sort of start leaning towards the idea that, well, if I have something that's showing me a certain degree of units, if I have a thermostat, for example, maybe what I want to do is I'd like the system to be aware of the user's preference, whether they're showing it in Fahrenheit, whether they're showing it in Celsius, what that looks like. And so then maybe I'll pack that data along, and I can change the preferences, notify the UI, and then start sending the data in that kind of new format. I would strongly recommend against that. When you're designing an API, one of the things you're looking for is consistency. You're looking for reducing the amount of potential trouble, potential confusion caused by anything that isn't really absolutely locked down and clear. So in that sense, I would say that your event data, the payload should be well identified, and they should have a unit associated with them. They should have a definition, that is fixed units. And then one of the rules of the user interface is to manage that presentation. So if you wanted, Fahrenheit, and the units are always going to be displayed in Celsius, then the UI's job is to, kind of apply that glue logic to the data as it's coming through before getting into the presentation stage. The other option, if you're really fixed, or if you're really stuck and you can't fix the data, is to at least pack the units of the data along with the data itself. This might be something that's required because your data is coming from an external source, and the external source itself doesn't apply this type of consistency. In any case, as a conveyor of data, you have the choice. And so if you know that the data is going to be variable, then you should look at ways to encode the data units within the data itself. So at least on the receiving end, you can start handling it in a consistent manner. The other piece here is that events should be kept small. And I put small in air quotes because what does small really mean? In the context of Storyboard.io, we look at our variety of different types of transport that we can have, right? We can have everything from shared memory blocks to system message queues to pipes or TCP/IP packets. And the idea of, what small is really varies pretty widely between these transports. We tend to, kind of use a general rule of thumb is that you're starting to think about kilobytes, you're probably starting to think too big, right? And you should be looking at what data is actually being transmitted and what's making it large. Is it the volume of data? Is it the nature of the data? Is it really something that, you should be re-examining the data protocol itself and saying, rather than trying to send, a couple kilobytes of event payload data, I should be either breaking it up, segmenting the data, allowing that data to be sent in chunks, and kind of handled by the UI a little bit more progressively. Or even better than that is if you have to send large data packets, don't send them at all. Really, if you think about, the situation here of getting a delivery in the mail, large packages require, the package to go to one central location, and then, the mail person will deliver you a notice saying that you need to go and pick up that data packet. And we can think of the same sort of analogy with our events. Kind if you have a lot of event data or it's a significant amount of complicated, sort of formatting to move it to kind of transcode it from one format to another, then don't do it, right? Reconsider what it is that you're doing. And I'm not saying don't do it as in don't get the data to the UI. Maybe the UI absolutely needs it, but consider alternative ways of notifying the UI or notifying the system about the availability of that large data. So I've kind of called out 3 different scenarios here that are all scenarios that we've encountered with customers before. The typical startup scenario is this, kind of this massive burst of activity as the system is initializing and everybody is trying to get themselves into a sane state. There's a lot of kind of trampling processes as everybody's competing for CPU execution time. And so, a great example here is why would you send a whole bunch of JSON encoded configuration data to the UI, giving it all the parameters and system startups when, the UI could actually just source that data itself. This may be something where you actually have dual modes of operation. Maybe at runtime, there is a possibility to do incremental, sort of updates of various configuration parameters as they come in. If you had some sort of system set up where you had multiple devices communicating, you need that ability to reinitialize or update your system. But for the most part, at startup, really, the system can go and get the data itself. So this is a good example of something where, sending the location of where you can pick up the configuration data rather than sending the configuration data itself. It does, force the UI to know that there's a file system, but you can set it up in terms of your implementation so that you can support both. We do a lot of work with white good manufacturers. We do a lot of work with people who are building devices that that require recipe information. And so where should that data live, right? Where should those recipe details come in? When I think about the recipe books that I have, they're hundreds of pages. It's a lot of data to be moving back and forth between a system model and a UI. That's something that really seems like it would be better to be left alone, in a very specific type of database, optimized for use, where queries can be applied against the database from the UI, and instructions from the backend, as recipe updates are applied, can simply come in as notifications, right? So again, this idea that really the event payloads that you're building are notification events, and they're not necessarily fully, kind of full data payload events. And I guess my last one here is a simple example where maybe you have a data acquisition system, and maybe what you're doing is you're acquiring a lot of data points, and you want the UI to be aware of those data points so that it can do whatever visual processing it makes sense on those data points. And so being able to put those data points into a block of shared memory rather than continuously updating the system with large blocks of events. If you're doing incremental event notification, this is sort of a series of, kind of a rolling chart, then, that might be totally suitable for the event flow. But something to kind of be cautioned about in that scenario is thinking about the update rate and thinking about, sort of the volume of data that's going back and forth. At the end of the day, you may have collected 1 million data points, but if you're displaying that as a chart or as a graph on a system, that's 640 by 480 in terms of resolution, you're not going to be able to process all those data points, and actually, display them. So there is some sort of, pre-processing that's going to have to go on to get that data into the UI. So thinking about, what that looks like and then incorporating that type of logic into your data API might be worthwhile, right? These are all things that, something to be kind of considerate of. And so at this point, oh, sorry, I got one more slide, and then we're into the workspaces. One more slide. Testing with events rocks. Yes, absolutely. This is my favorite part because it really kind of leads us into the, kind of some of the work in the workspace that we're going to look at. Is that the nice thing about working with events is this decoupled nature is that you don't care as a UI process where the events are coming from. And similarly, as a system process, you don't care where the UI events are coming from, right? All you care is that the events and the data payload that you want to work with are either being generated, and you can validate that, or that they are, that they're coming into you in the way that you expect. And so this source, kind of agnosticism is really, really useful if you're a tester, right? If you're looking at the testing angle of your product and you're thinking, how do I validate APIs? I mean, you may be thinking about unit tests, but then you have to scaffold a lot of work together. And then those unit tests, can they be used by developers? How much of the system has to be shimmed out? Because events tend to be relatively small, because they're, kind of very well encapsulated, they serve as a great watch point or slice point across your system, right? Where you can actually stub in, a system process to be able to pretend like you've got a system when you're developing your UI. And similarly, while you're developing your system, you probably don't really care. If I'm working on a device driver and I'm feeding data into my model, I don't really care what the UI is doing with it. I really just want to be able to validate that I'm giving the UI the data that it needs in the format that it's being told. Whether or not there's a fully formed UI behind that, sucking up the data and displaying it, doesn't matter to me. And the same thing on the UI. I don't probably care much about, the nature of the hardware that is generating the data. As long as I have data to work with and I can validate my workflow inside the UI, then that's really what's important to me, right? So, you've got these two concerns who, not to be callous about it, but they don't really care about each other, right? They really care about doing the best possible job that they can do and providing their service. And that's what the events allow us to do, is that give us this slice point, allow them both to work independently and in parallel, but with a solid API that allows them to connect together. And so we have some tools that we've built in Storyboard that allow us to, kind of work in this fashion. And that's really what I'm going to talk about next. Is I'm going to jump into Storyboard and we're going to look at that. We're going to look at, sort of how we can use some of these tools as, kind of these slice points in between the UI and the system. So with no further ado, I'm going to come out of my PowerPoint slide here, and I'm going to jump over to Storyboard. Now, because we get so much grief about always using thermostats, we switched our standard models to using coffee machines. So coffee machine is something that everybody can relate with. If it's not a coffee machine, consider it as some sort of other tasty beverage dispenser. This coffee machine, this base UI, is something that's being put together inside of Photoshop, being imported, and our graphic designer here has actually done most of the work to get this up and running, right? So here's kind of the basic operation. I start, I select a size. Once I have a size, then I need, this is presumably some sort of machine that has a pod system, I need to make sure that there's a pod, and then I can go ahead and I can brew it, and then away we go with our animations. Now, this is entirely synthetic at this point in time, right? This UI is being developed, right, by the graphic designer, working with, some usability experts to make sure that, sort of the general flow is exactly what we've been looking for. Now, if we were to, start working collaboratively as an engineering team, one of the things that would allow the UI designer to take this and start moving it more towards being a ready-made application is if, rather than sort of dealing with animations and events, and they could actually start dealing with the real data. And so this is the critical point where the team comes together and the team wants to talk about the API, right? And this is the backend team and the UI team talking about not just the data that's available, but the best way for that data to be put together. And for that, we provide a storyboard event editor. And so this is a great collaborative place for event definitions to be flushed out. So what we might do here, for example, we might say, well, one of the things that's really important to us is this notion of being able to know whether or not there's enough water for me to have a coffee, right? So we'll say, okay, well, that's good. The backend has the ability to communicate that. And so I can say, let's add in a new event, and we'll call this our water status event. The one thing about the UI event editor is that it is framed in the context of the UI. So, we can identify this event as an incoming or outgoing or self event from a UI perspective. So we'll say this is something where from the backend water notification, say that. Now, you'll notice here in this field, there's some other options here. This is the event name that we're expecting to communicate, right? Sort of agree on. It should be descriptive. It should have some meaning to it. But even more important is the information that we're going to put into our event flow, right? We're going to have some data coming in along with this water status, and so we might have something like, for example, what is the amount? And this is where the engineering team is going to have some input. The UI team is probably more interested in just knowing what type of data is there. The engineering team is going to be interested in, well, what type of data do I actually need to classify it as, right? Is this a signed value? Is it an unsigned value? What are reasonable limits on how much water we can bring in? This is where we can articulate some of that information, right? So here we might say that this is a 32-bit unsigned integer. And so we'll go ahead with that. Now, being a 32-bit unsigned integer, what was one of the things that I had called out before? We should talk about units, right? Units are in milliliters, right? This allows everybody to be on the same page about the data that they're getting. So if you're in the UI and you're an American UI, you want to show it in kind of ounces. Now I've got to have a conversion routine to go between milliliters and ounces, right? Perhaps you're in Europe and everything is a deciliter. Now I need to make that change. So let's go ahead and we can also set some limits here. These limits are really kind of imposed for the UI. And once I've done this, now I've got something where this water status event is locked in. It's an event that can be referred to and shared by both the engineering team and the UI team. Looks like my limit didn't get stuck there. Say that up. And what's interesting here is that this builds up a description that now can actually be used inside of a simulation, inside of the backend. If we want to, we can go through and we can actually do a data export of this. Oops. Storyboard, we can export the event headers that we define. And so we can build up this, kind of this common API based around events. And now with this event-based API in place, what the UI team can do is they can actually start using these events in the context of their UI. So instead of simply, kind of running and saying, well, this is what it's going to look like, here are all your sizes. Now they can actually add in that extra little bit of plumbing, that extra little bit of information about, well, what happens when I don't have enough to make a large coffee? Should it disappear? Should it be grayed out? Should it be X'd out? That would be something, those type of details are typically left to the last minute when the engineering team starts putting the reality around, providing the data into the system. But now that we've defined events, what we can do is we can actually start looking at that directly inside the UI. So I'm going to jump ahead here into my navigator, and I'm going to open up this second project, this coffee app base modified. And what I've done in this application here is I've gone a little bit further. If I look at the event editor, you can see here I've actually put in a number of additional events, right? We have a water status event, which is actually giving us information about the water level. We have a pod status event indicating if there's a pod present or not, a brew status indicating that, once we've walked through the UI, we need to tell somebody about what we'd like to do. So how are we going to do that? Well, now we have a status event for that. And then a brew request, the request is the request to start an operation, and the status is feedback about that operation. So if I look at what this application looks like now, when I run it, it's actually quite a bit different. Synthetically, I'm still doing animations, I'm still interacting with the user, but what you'll notice here is there's some functionality right away that is called out. We needed to make some UI changes because what happens when we don't have enough water? Well, we didn't take that into consideration in the base UI. So what's great here is that the design team is actually now able to look at these scenarios and say, oh yeah, you know what, we need to craft that. And they can do that at the same time that the rest of the system is being put together. What's even more interesting is that we can start now looking at what does it mean for us to actually, sort of simulate this more fully. Before, when it was all just the UI elements, we couldn't really interact with it other than just, superficial clicking and sort of seeing what the flow is. Now, what we have is we have all the events defined. So what we can do is we can actually start talking about simulating our applications. And this is really, really important. Right? I'm going to open up this simulated project that I've created here. This is that slice point that I was talking about on the last slide. This is what's going to allow us to have two teams working in parallel and kind of running at full speed, because each team now has the ability to work with essentially a well-defined socket plugin interface, and they don't need to have all the functionality defined. They only need to have the functionalities that they need in the moment while they're developing, and they can do that, right, because they have a well-defined, kind of interface point, and we have a variety of different technologies for generating data out. So if I look at, what I've built here is we've got this coffee simulator application. Again, it's a storyboard application running on its own, and it's going to, sort of communicate to, ideally, it'll communicate to a UI front end, but it doesn't really matter who it's communicating with, because we're going to have some fleshed-in controls that'll just simulate, here's the water level, here's the pod, kind of presence. And when I do this, when we look at this, right? Again, whoops. Make sure we don't have too many of our storyboard applications running here. So my low water dispenser was already running. Let's just kick that off again. Just be nice and clean, right? So I can run my UI, and then I can come in and I can run my simulator here. And I'll get into the, kind of the nuts and bolts of what's going on behind the scenes here in a second. But now what I can do is I can actually, totally within the context of the UI development, I can actually start seeing, what does it look like, when I start changing this, now, is this the presentation we want? Well, we can go out, we can, sort of shop this out with users to get a little bit more feedback, right? A little bit more refinement, right? Before, they were only able to see what it would look like in an ideal scenario, but now we can start talking to them about, well, what about these less than ideal scenarios? If these scenarios, are they worthwhile? Do you like the presentation? Do we need to do something different visually? You'll also notice here, right, that we have the ability to say, oh, well, what happens when the pod wasn't present? We were prompting for it, but we didn't really consider what would happen if it wasn't there. Now we can put it in or take it out, put it in or take it out and see what that looks like, right? And then we go ahead and we say brew. Previously, we had an animation that was running, and that animation was running pretty artificially. It wasn't really reflecting, the speed at which the coffee would be made. It was kind of like, let's just visually show something jazzy and get out of here, right? And now what we can do is we can actually see, well, let's play with this. We know what a flow rate really might look like. We know actually how long it would take. Maybe that animation really is kind of too choppy. Maybe that animation is too chunky. We need to actually fix it. And what's really interesting about this is this gets us into this notion of open and closed systems. And I know that was one of the topics we had mentioned in the abstract, but you'll notice here that there's a lot of visual activity going on that has nothing to do with the simulation. And that's because there's a lot of activity that can be done without necessarily confirming with the backend system. So for example, as long as the water level, is suitable, we can pick either one of these. We don't need to, sort of choose medium and then tell the backend we're doing a medium, or choose small and tell the backend we're doing a small. We can do all sorts of visual, kind of presentation, visual graphic, visual interaction, and then only choose to engage with the UI, or with the backend when it's required, when there's some imperative statement to be made. That would be more of an open system. A closed system would be something where really the UI and the backend are a little bit more tight-knit, right? So our events that we've defined here are very kind of imperative statements. The water level is this, the pod present is this. We're not asking permission to brew a small coffee. There are certain scenarios where you may want that type of lockstep behavior of, I'm asking permission and I need to talk to the model, so I'm going to generate an event. The UI can then have an affordance that allows you to wait for the system to respond with a positive acknowledgement or a negative acknowledgement about that request. And that allows the UI to continue to remain interactive, and allows the user, sort of the sense that the system's not locked up while you're going back and forth with these communications. So one thing I want to just kind of look at how this was implemented, right? So on the, kind of the coffee side, if I take a look at our, sort of our brew events here, you'll notice, let's go for status events, right? You'll see that we plumbed in these status events. These are standard storyboard actions. I'm assuming that, in the context of this training, adding actions to your storyboard application is, sort of well in hand. If I look at how we've organized things, this is a little bit interesting here. What we've done is, we've got two different scenarios here where we've got a call out of all the brew operations, right? And the brew operations here are all interacting with the UI based on the events, based on the system data changes that we've got. It's interesting here, we've done a little bit of work to, kind of localize some of this data so that, we can have it abstracted. This is just a quick sample, right? But you can imagine that here, if we needed to work dynamically with different content, right, different brew sizes, this is where we would put that information in. What's more interesting is the simulator. To me, the simulator was assembled using a number of our widgets, our components, right? Just bring those out quickly so that we could assemble some quick, kind of engineering style elements. These components are interacting with our system, as callbacks. But what they're using is they're using a simulator stub that we've written. And what's interesting about this is the simulator stub actually allows us to work with the system in a couple of different scenarios. We can either interact with the system, sort of interactively with this simulator UI, or we can run this simulator using this functionality and run it all from the command line. So that's something that, when we talk about those slice points and, kind of what facilities are available for users in different capacities, this is one of those things. So if I were to run our application again, not the simulator application, but let's run the storyboard application. Right? If I were running our storyboard application again, and I go to the start page, I can see that I'm, I've got this low water fill dispenser. I'm going to go to my command line, and I'm sitting inside of the Mac version of the storyboard engine, but this would be the same if you were on a Linux system or some embedded device. And I can actually now use the functionality of SB Lua to drive custom Lua scripts. And SB Lua is a command line interpreter for Lua, and it allows you to, just like you would write a Python script or a Bash shell script, you can write a Lua script that runs independent of any storyboard UI elements, but it has access to all of our channel communications. So you can send events, you can receive events. And so what we can do here is, if I run the simulator now, you'll see here, the simulator starts off by sending out a couple of events, the water status and the pod status, and then it's just in this waiting mode, waiting for a command. And I can come into the UI and I can select, maybe like a medium coffee, and I can say brew. And what you'll see here is that now the simulator has actually received the event that it wanted to do a brew, and it went through sending up brew status events until it was all finished, and then it updated the water amount. And now the simulator is sitting here waiting. And so I can come back in and I can say, okay, well, now I'd like to have another coffee, right? And we should see that this amount here, the water amount, is slowly going to drop, and we're going to come back in. And so what I see now is that my simulation is actually changing, right? And so from a test perspective, this is great because I have no back end that is actually generating this data. This is entirely synthetic. So for your testing team, this is amazing. We're showing it here in the context of interacting with the UI, but you can do a similar story with the backend, right? The backend is communicating to a UI and providing it with data. You can use commands like SB Lua or IOGen or IOReceive to receive those events and actually validate their payloads, right? So this is a fantastic functionality that we've got sort of sitting here available for you. So let me kill this simulator off. The other piece we haven't really talked about is the fact that we could do some of this work directly from within Storyboard. We could use the IO connector to generate information for testing purposes. So for example, if I wanted to come in and make sure is my water level working, I can come into the water status here and I can make some adjustments here. Whoops. My number range is way off. So if I put it into say 200 and we take a look at the UI, we should see there's enough there for a small. And we can can make some adjustments this way. The IO connector is great for very simplistic data. As you get into more sophisticated change scenarios, where you want to be able to send or receive events, you usually have to move from the IO connector into kind of more of a scripting environment. So the last thing I want to talk about, and we're going to try and get it all on screen here, is this is all great. This is all working in my local environment. What about when we talk about the target? What about pushing the content to the target? So I can run this simulation. I can do an export and actually run it directly onto the target. Let me just make sure I'm running the right one here. I can push this target down to a target, and I've got a target running here. This is an AM335 Gigabone. Hopefully, I'll be able to kind of sort of see it. I'm not switching over to the full camera feed because then we'll lose the desktop experience. But if I go and I run this right now, this is going to do an export of our storyboard design and push it down to the application here. You'll notice here we have the ability to start it automatically. I'm not going to use that because I want to be able to see some of the command line output. So I go ahead and I run this. The export is occurred. And now I can come over to my other command line terminal here that's already connected, and I can run this application. And you'll see here, the application is up and running. But we have the same type of challenge, right? Is that we don't have the water connected. So now I'm running on the target and I'd like to kind of get the same data flow, kind of be able to use that. Well, I can do the same thing, but I can leverage the fact that we have the ability to do TCP/IP, right? We can shuffle our events not just over local transports, but over TCP/IP. And what I'll say here is I want my same channel name, but I just wanted to connect up over TCP/IP. With any luck, what this will do is this will connect up here, and we can see my application is running in behind the scenes. And we've got the ability now, if I use my remote channel here, I should be able to change my water status. And let's see if we can get everybody on the screen at the same time. As I change my water status, you'll see here, right? My target is actually responding live, and I'm doing this from, kind of within the designer. What's really neat is I can actually take my simulator, and with a few small changes, you may have seen it at the top here, with a few small changes as far as where my UI and local channel is, I can set up my simulator up so that my simulator can actually communicate over the network, and I can push my UI down to the real target and interact with it that way. So a lot to digest. A lot of this material, again, is covered more comprehensively in our storyboard training course. But we wanted to kind of give you a little bit of a high-level overview of, why we think doing event-based design and architecture is so important, and why it really liberates you from, sort of that source independence, gives you a better way to simulate, better way to test, better way to validate, and work with your systems. So Scott's going to tell me I've gone way overboard at this point in time. So maybe what I'll do is I'll kick it out for any questions that we may have, and I'll take a few minutes now.
I would never say that. More information is the better. Everybody's learned some great things. So we do have a couple of questions. So the first one, is there a special process with Storyboard to push the events or data that you talked about in a cloud model?
So there is, with the last release of Storyboard, what we allowed targets to do was to work directly with each other, kind of over a dedicated TCP/IP channel. That gives you a lot of flexibility in terms of, how you might want to route data or how you might want to actually manage data. Prior to that, we actually had a separate model that was a little process oriented. Our Storyboard.io API is a library of functionality that you can really plumb into anything. So if you wanted to have a cloud service with data and you wanted to kind of reflect your data through that, certainly you could. There's not something that we build directly into Storyboard for it, though.
Okay, perfect. Another question, can you expand on the data alignment you mentioned when it comes to memory?
Absolutely, absolutely. Maybe probably the easiest thing to do is just pull that slide back up here. If you take a look at what we're talking about on this slide, one of the challenges is that our serialized memory block is just that, right? It is a linear, contiguous, serialized memory block. And so if you have data structures that are not tightly packed together, then what will happen is the interpretation of that by Storyboard will result in potentially holes, right? And this is something that is, it's a bit of a compiler specific option. It's a bit of a low level detail, but for example, here you can see that in order to satisfy, the natural alignment for the A variable, it has to land on a 4-byte boundary. But the B variable can land on a 2-byte boundary. So if it starts at the 2-byte boundary, we can't put the variable A immediately after it. So the compiler is going to insert padding quite silently, right? And if you were to run the compiler on this structure and kind of put the size of information in there, what you'd probably find is that on most systems, without any other options, you're going to see that the alignment is going, or the size of that entire data structure is going to come back as 8 bytes. If those members were flipped, then the alignment of the individual members are going to fall on their natural boundaries. And so A being on a 4-byte boundary, the allocation of the memory is probably going to give you back that 4-byte boundary. Then B can sit on any 2-byte boundary, so it'll sit on the first one, and now you're going to see a much more, a slightly smaller structure, but you don't have this hole in the middle, right? Which is really the important part. If you're describing the format string in this case would have to encompass the fact that there's this alignment hole probably introduced by the compiler. Now, there are special pragmas that you can specify to the compiler to say that you'd like it to pack data stream or data structures to avoid this. But you also need to be cognizant of the fact that many chips will perform in a suboptimal fashion once you start moving off the data's natural alignment. Hopefully that was enough, kind of enough context. If you're ever looking for more information, you can certainly reach out to our support channel, and we're always happy to kind of get on a call or do a quick screen share to talk through some of these concepts.
Perfect. I have another one. Is there a tool within Storyboard to allow for determining how big or small the event data packets are that you talked about?
There's not a tool directly within Storyboard to do that. If you're looking at complex, we don't have a very complex scenario in here. If I take a look at these events, we don't have a scenario that's very complicated here. However, we can export this data as the C structure, and when you export the data as the C structure, you would actually be able to see it from a compiler perspective in terms of its footprint. Now, that's only relevant for structures that are composed of fixed values. If you're looking at structures that involve kind of dynamic strings or null terminated strings, then that would sort of all go out the window. But that's a great feature, right? That's a great feature request for us to put in.
Perfect, and I'm going to note that one and get that one into it. And then the last one is, I think you kind of touched upon it with the first one, but did you say that I don't need the target hardware on site to use Storyboard I/O connector?
You do not need the target hardware on site. So yes. Now let me interpret that question a couple of different ways. From the first perspective, if you're only working at your desktop and you're just working with local communication channels, and that was the scenario I kind of ran initially, you don't need to run remotely. You can run and simulate everything locally. And this is one of the big benefits of calling out an event and data-based API, is that you're not having to recompile some sort of a shim library where you have to make function calls. You've got the events, and it doesn't matter where the events come from, whether they're simulated or whether they come from a real system. So in that context, yes, absolutely, you can do everything without having a remote target. Now, if you have a remote target, the question is where does the remote target actually have to be? Whether this remote target that I'm connected to here is sitting next to me with this webcam, or whether it's in my lab far, far away, really doesn't matter. As long as I have a network connection to it, I can leverage it and take advantage of it. Now, here's the challenge. We're talking about doing some UI aspects of sort of validation and verification. It may be hard for the thing that you want to do not to see the display. Now, we do have technologies that also allow you to capture the screen and display it, save it to an image and kind of work with it that way. And that's what our test execution environment does. We have a full lab of hardware that runs automated testing behind the scenes with nobody looking at the actual screen displays, because we're generating screen captures of the data that we're interested in and using that for our analysis. So hopefully I kind of gave you an answer there. You don't need to have target hardware. The target hardware doesn't have to necessarily be directly connected to your machine. If you are working with it, you can use it over the network, and depending on the configuration, you may never need to even look at it.
Perfect. So let me just go back to sharing just to kind of wrap things up. All right. Oh, that wasn't the screen. There we go. Hopefully everybody's seeing the end of the presentation. So I just wanted to quickly just kind of wrap things up for the end of the session. I just want to thank you for sticking around for the extra time, but it was some great information comes across. Definitely, you know, depending on what stage you are, if you're not aware, if you haven't used it before, but I'm sure most people are, but I just want to call it out that we do have a variety of demo images for a large variety of different hardware platforms that can be accessed off of cranksoftware.com. Definitely go if you weren't aware of it, or if you're going into a new project and you're looking to evaluate that particular hardware, whether it's using the coffee app that Toma talked about, or whether it's it's one of the other applications that are there for you. Definitely, if you have questions or you're looking to definitely expand upon your knowledge of Storyboard in between these monthly sessions, definitely take a look at our Help Center, because we have a large variety of information, from knowledge-based articles, from getting started videos to a little deeper dive videos, and just to kind of help you out and just to get to know Storyboard a lot more. And again, from there you can also connect with our support team and pose any questions that you may have, like Toma mentioned. And then of course, to make sure that you continue advancing your Storyboard knowledge, like I said, we have another advanced user training session coming up in the end of May. This one is about configuring Storyboard for your Linux system. So keep your eyeballs peeled for those ones coming across your email inbox, or if you periodically go to our web page, you'll find a Learn section. Within that Learn section, you'll see the webinar section, and we have a variety of different webinars going on, whether it's working with co-presenting with different vendors, whether it's NXP or ST, or individual advancing learning. And we also have, just to kind of call it out in case you weren't aware of it, every month, I think it's every couple of weeks actually, we do a live YouTube series where well, the last couple folks like Toma have been kind of diving in and talking about different elements about the UI development industry, really kind of more of a thought leadership. So if you haven't checked it out, you can access the past ones, but those go live, I think it's every Tuesday or Wednesday. So again, you can find all that great information within our webpage. So with that being said, I just want to kind of thank you all for your time today, and for sticking around and listening to me rant at the end here. But definitely, if you got any questions at all, we have a team of people, whether it's our support folks, whether it's our sales folks, our FAEs, or even folks like myself in marketing. We're here to assist you however we can. So with that being said, have yourself a great day. We'll talk to you soon.